See, Ostwald Walker method is actually used for the relative lowering in vapor pressure. We know relative lowering in vapor pressure is P0 minus Ps divided by P0. This is relative lowering in vapor pressure, which is equal to mole fraction of solute. Okay, this we know. So to find the relative lowering itself, we have an experiment, that is Ostwald Walker method. From that method we will get this value. Okay, how it is actually, the setup, how it is done. Here you can see that different like bulb kind of thing is there, where the solution is there, solvent is also there. Now this dry air is allowed to pass through the solution as well as the solvent. So first it is passing through the solution content and then it is passing through the solvent content. See, dry air has a tendency to move, right? It has a tendency to move. So definitely it will go out through the passage wherever the openings are there, it will pass. Okay. So, but here you can see that from the solution, a particular solvent, see, relative lowering in vapor pressure is happened like when a non-volatile solute, this things you can see, a non-volatile solute is dissolved in the solvent. So that doesn't have the capacity to vaporize, but the solvent molecule will vaporize. So when the dry air is passed, for example if you take like water, okay, so if dry air is passed, so the moisture content from the vapor will definitely absorbed from the absorbed by the dry air. Okay, so rest of the dry air will move, because dry air always has a capacity like tendency to move, diffuse we can say. Okay, so definitely the rest will be, some of the dry air will be passed to the next content and another again it will be passed to the next content which contains solvent. Now see how much of dry air is passed. Okay, how much of dry air is passed, that much like whatever the moisture content is present in that will absorb the dry air and it will become a saturated point. Why? When the dry air is passed, this moisture content actually absorb this dry air, I told. Okay, so once this is absorbed, the equilibrium between, see here that solvent is there and solute like this not solute, that vapor phase is there. So once the vapor phase, whatever molecule has been absorbed by dry air, the equilibrium between vapor and liquid got disturbed, right? So once the vapor got removed by dry air, what will happen? Again the liquid will vaporize back to the vapor. Liquid will convert it to vapor. So there will be a decrease in the mass or weight will be lost by the solution. There will be weight loss the solution. That weight loss will be directly proportional to, we can say, weight loss by solution, okay, is directly proportional to, see here, if it has more tendency to vaporize, definitely that much of solution or that much of vapor will be absorbed by dry air. Okay, so more dry air will absorb more content if the vapor content is more. Okay, dry air will absorb more like which one, gaseous one or vapor, if the vapor content is more. That will happen if its vapor pressure is more. If the solution's vapor pressure is more, definitely more dry air will get absorbed. So more mass will be like, there will be more weight loss. Okay, mass will be get vaporized. So we can say that weight loss by solution is directly proportional to vapor pressure of the solution. More the vapor pressure of the solution, more vapor content will be there, so more dry air will be absorbed. Now rest of the dry air, okay, because I told you already, the dry air has a tendency to flow, or we will say that diffusion. It has a capacity, or it has a tendency to diffuse. So definitely the dry air will be passing here only. But those dry air, which is passed to the next one will be definitely rest, like other than which got absorbed. right, other than which got absorbed. Like moisture content cannot absorb because moisture content is already saturated with this solvent molecule. So the rest of the dry air will only absorb, okay, these two are solution. When it is going to this content where the solvent content, the rest of the dry air which is passed can absorb the solvent molecule. So now what it is depend, see here. Now suppose separately I am taking a solvent is there, a solution is there, a solute particle is there. So if you mixed a solute particle, more solute particles into this one, we know that more relative lowering or more lowering will happen, because according to Raoult's law, according to relative lowering in vapor pressure, you definitely know that more the solute, more relative lowering is directly proportional to mole fraction, and once the solute is non-volatile solute is mixed, there is a lowering in vapor pressure. Okay, so if there is a more lowering in vapor pressure, I am saying, okay, here I am taking an example, just a second. See, in this solution, suppose this solution, more lowering in vapor pressure, P0 minus Ps is more, okay, more lowering in vapor pressure is there. In that case, less vapor only will evaporate, means vapor pressure less means in gas phase less vapor, right, less vapor. So vapor pressure if is less means more lowering in vapor pressure, then in gaseous phase only less vapors, due to which one, which we are saying here. Okay, so here in this case, here you can see, here there will be less vapors formed if already the vapor pressure of the solution is less. So if this content is more, if more lowering in vapor pressure is there, only less amount of solvent will be, or vapor will be formed here. So if less amount of the vapor will be formed here, then dry air will absorb only, dry air will got easily saturated with here. Dry air will be easily saturated with here, and we can say that more dry air will be passing here. Means if here only less dry air got absorbed, here more dry air will be passed through the, here, not here, through the solvent container. More dry air will be passed through the solvent container. So we can say that if lowering is less vapor here, lowering is more, less vapor here, so more dry air can be passed through the next content or solvent. So we can say that the same phenomenon will happen here also. So here, if again dry air will be saturated with the solvent also, now solvent will evaporate with more content if more dry air is coming. Okay, here we can, because definitely we know that P0 is greater than, see this one, definitely we know that P0 is greater than Ps. So definitely there will be more vapor pressure here, right? Definitely there will be more vapor pressure there. So definitely more dry air will be get saturated with this solvent. But that saturated is dependent on how much lowering is there, so that more dry air will be get passed to the solvent. So we can say, now we can say weight loss by solvent is directly proportional to P0 minus Ps, and we also find that weight loss by solution is directly proportional to Ps. Okay, now after this one, what happened? See here, after that again the rest one, okay, rest one. Now not the rest actually, see here, now all the moisturized dry air got moisturized from this content. All the moisturized dry air is going to pass through this one. Okay, all the moisturized dry air is passed through the dehydrating agent, Now what is the role of dehydrating agent? Dehydrating agent will absorb the hydration, or it will absorb the moisture. So all the moisture will now pass here, and those moisture will be absorbed by CaCl2 or an dehydrating agent. So what, like, see, weight or the moisture formed by dry air absorbed moisture was directly proportional to this one as well as this one. Okay, if more this one, more dry air absorbed moisture, more this one, more dry air absorbed this one. So weight loss by solution and it was directly proportional to this one. From the weight loss we can say it's like a relation, it's not equal to, it's just a directly proportional. Okay, now so whatever moisture got absorbed will be the sum of, now whatever moisture absorbed by dehydrating agent, okay, will increase its weight. So we can say that gain of weight by dehydrating agent is directly proportional to, see, from where the moisture content has been come, from here plus here, right, from here plus here the moisture content here. Okay, so it will be directly proportional to, as a result of P0 minus PS plus PS. Okay, now PS and PS cancelled, we will get directly proportional to PS. Now if I say that weight loss by solvent by weight gain by dehydrating agent will be equal to, or we can say directly proportional, it will be equal to, because we are taking the ratio, will be equal to P0 minus PS divided by P0, which is called as relative lowering in vapor pressure. So relative lowering in vapor pressure can be calculated from weight loss by solvent, from weight gain by taking the ratio of weight loss by solvent and weight gain by the dehydrating agent. So this is actually what we call as Ostwald Walker method. I hope you understand. Thank you.